I'm here in Broadcast Depot. My name is Marco. I'm from Axel Technology. Today I'd like to talk to you about a very interesting product. It's called Multi-Cross Converter. As you know, we have a lot of glue products on the market, small boxes that convert from SDI to HDMI or other physical formats. Actually, in this new world, we have to treat and deal also every day with non-physical formats like IP formats, like IP for broadcast, which is NDI, or generally speaking, IP used on the internet with RTMP or RTP and other formats. So for these formats, there are not actually a lot of hardware devices, hardware boxes that allow you to convert from one format to the other. That's why we came out with a software application which is actually a glue for all these formats which are difficult to convert using hardware devices. So the application runs under Windows. Here I have a Windows computer. Inside the computer I have a decklink card which gives me the possibility to interact also with physical formats like SDI, inputs and outputs. And the application presents itself like a small multi-viewer, where in each window I'm actually doing a conversion. So let me give you some examples of what you can achieve with this application. So on this drop-down list, what I have is the possibility to choose among my sources. So I have some bars, which is just a bar generator. Then I have an audio-video device. That would be my Blackmagic card or my Azure card or something else which gives me access to physical formats like SDI or HDMI. Then I have a file. That's what I'm doing here. I'm just playing out a file which I have on my hard disk. Then I have IP, which is IP format like RTMP, RTSP, RTP, and all the other ones. Then I have NDI, which is the new tech, low latency, high quality video over IP format used in LAN. And then I have WebRTC, which is a Google format. We're going to talk about this. So what I'm doing in this first box, I actually have a video playing out. And what I can do is I can apply some aspect ratio conversion, some conversion into video. I'm keeping it just normal. I want to convert, and I just don't want to convert the resolution. I just want to convert the format. So I'm from a file, I'm actually outputting directly in an NDI format. So in my second box, what I'm doing is I'm actually picking up that same NDI, and I could pick this up from whatever computer on my LAN, and as you see, my NDI receiver is actually signaling that the same computer has a source, and I'm visualizing that. As you see, you have almost no delay. This is a characteristic of the NDI. Of course, you can use the NDI only on a high-speed LAN, like a gigabit LAN or a 10 gigabit LAN. Then what I'm doing, I could actually do a conversion here, but a dimension or resolution conversion. But what I'm actually doing here is I'm encoding to IP. And in the encoding box, I have all my IP formats, which can be RTMP, UDP, DVB compatible streaming, SRT, which is let's say a low delay, like RTP format, very new. I have RTP in ProMPEG, RTSP, live smooth streaming, which is Windows things, RTMP with Flash Media Live Encoder, and another Windows Media. In this case, I'm encoding an H.264 and AAC onto a local server, RTMP server, which I have here only for demonstration. But actually, usually you would use a cloud-based server where to send your RTMP, maybe to embed it into your web page or simply send it to Facebook. That's the format that you would use for that scope. In the third window, I'm actually catching the RTMP as a decoder. So this gives you an idea that you can also decode that. What type of IP can we decode? We usually say if VLC can decode it. VLC is a very popular software that actually is compatible with almost all IP formats. We use on the bottom the same technology that VLC uses. So usually if VLC can see it, we actually can decode downloaded as well. So a lot of compatibility there. And the first thing that you see is that you have a lot of delay between the source and the target. And this is simply because it's a characteristic of RTMP. It's very robust on internet connections. So if the internet goes up and down, it adapts to the quality of the connection and actually introduces delay in order to give you a nice and smooth playback. And then what am I doing with this? I'm going to AV, audio video. So in this case, I'm actually outputting to a deck link in SDI, and I'm sending the SDI to my mixer, and I see it in my multi-viewer in the 7th box, the lower left-right box. So that's what I'm decoding from the 3rd window, and I'm going there. And then my mixer is actually applying a downstream key graphics on top. And then in the 4th window, I'm actually capturing the output of the mixer from my SDI, my deck link. And what I'm doing then is using the WebRTC protocol. WebRTC is a very interesting protocol which Google made to achieve voice conferencing in the beginning. It is used by a lot of telephone application or voice conference application, and it also includes the possibility to send video. We are using this technology to actually send high resolution and high quality interlaced video over that transport protocol. And what's the advantage? Well, for voice conference, you need very little delay. And this is what we are obtaining with this application. Actually, the results are much better than any other hardware box we tried until now. And what I'm doing is I am encoding to WebRTC, and then on the last window, I am decoding from WebRTC, receiving the same signal, and sending it out to another SDI output of my video mixer. So actually, let me reset that. Okay, there you go. So actually between SDI 7 and SDI 8, what you can see is a very small delay. We're talking 100 milli, 120 milliseconds. Of course, I'm doing this on the same computer. So if you would have two computers on the internet or on a dedicated fiber line, you would just have to add the ping of the single connections to that. So with 120, 130 milliseconds, you actually are getting a quite fast video transport, and you can go up in quality, 20 megabit, 30 megabit, 50 megabit. So an application for this that we already have used is you can position your cameras on a studio and remotely have your video mixer with your SDI actually mixing those sources with very low delay, and then send back the signal to the remote studio to maybe display it on a video wall or do other things with it. So a very interesting technology here. So practical uses. Well, if you have a technical room full of glue, full of converters and so forth, usually a machine like this would be able to do all the conversions that you cannot do in hardware. So you can use it as decoder from IP and then put the signal in the SDI router, and then you would have that IP signal always available in your SDI routing system. Or you can use any window to encode to your favorite live CDN. So one to Facebook, one to YouTube, one for your website, or use the NDI to SDI possibility to integrate in a hybrid, let's say, IP production center and use it as a NDI to SDI converter, or at last use the WebRTC feature, which allows you to have high quality video with low video delay over, let's say, in networks which are not as reliable as a LAN, so an IP connection like internet or a dedicated fiber or something like that. Okay, thank you very much.